Morning class, you're welcome. In this video we're going to solve 2 or 3 questions. Then after that we're going to see another video for more questions, and then that is probably going to be the end of this topic, okay, because we're done with it. So let's see this quickly. In this video, this question, a student has 273 matchsticks with which to make a pattern of nested triangles. Okay, the figure below shows the first 3 triangles. So we have first 3 triangles, the first one, the second one, and then the third one. If all the matchsticks are used, how many matchsticks will each side of the biggest triangle contain? Solution. The first idea here is to be able to establish what kind of sequence this produces. This produces an AP, obviously, because in the first triangle we have 3 sticks. Second one we have 6 sticks. Third one we have 9 sticks, and this produces an AP. So I can have an AP of 3, 6, 9, and so on. But I can also look at it this way by considering, since I'm dealing with the sides, by considering each side. So if I look at the first side of this triangle, it has 1, it has 2, it has 3. So you see, this is another way I can look at this particular problem, okay? But mind you, put something in your mind. If I'm looking at this kind of AP for this triangle, then the sum is 273 matchsticks. 273 matchsticks will produce this kind of triangle. But if I'm looking at a side, or the sides of these triangles, then I'm looking at 1, 2, 3, and so on. Then how many matchsticks are going to produce these triangles of one side? 273 matchsticks divided by 3. Okay, so I think I'll look at it like that. So let's consider sides. Considering sides, we have the sequences 1, 2, 3 continuously instead now. But now we have the first term is going to be equal to 1. The common difference is nothing but 1 also, because 2 minus 1 is 1, 3 minus 2 is 1, and so on. And then the sum I'm dealing with, Sn. I do not know the last term, so I will say Sn is equal to 273. Now divide by 3, because the total sum is 273, and I'm looking at only the sides. So I'm going to have 273, 3 here is 91. Okay, now that's it. Okay, now n is question mark also. N is question mark. I do not know n. Now I'm going to find the last term. That's what the question says, the last term. Sn is equal to this, so I'm going to find the last term. So in other words, find n. If I can find n, then I'll find that nth term. So Tn is question mark. That's what I'm finding. This is actually what you're finding. The last term. What is the last term of the biggest triangle? Okay, now we have to set up this. We have those 2 formulas. Sn, as I gave you, is equal to n over 2, then a plus l. Can I use this formula? If I cannot use this formula because I do not have the last term. Okay, because I do not have the last term. Yes, but I can use the other formula. Let's state it quickly. Sn is equal to n over 2, 2a plus n minus 1 d. This is the other formula. Okay, you have to know this formula offhand. Okay, you have to know it offhand. So with this formula, I can set up my Sn to be equal to this 91, and then my d is given, my a is given. Find n, simple. But if you use this one, you have a problem with this. Okay, so you have to refer back to this one. So now So this is what we're going to use, this formula. Okay, using 1, let me call it 1 or 2. Here is 1. Using 2, we have, let me set Sn as 91 now. We have 91 is equal to n over 2 into a, that's 2 times 1, okay, plus n minus 1. The common difference is 1. See that? So I have 91 is equal to n divided by 2. Then I open this bracket. This one's inside. This is 2 times 1, 2, plus n times 1 is n minus 1, like this. So I'm going to have 91 is equal to n divided by 2. So we have what? This is going to be 2 minus 1 is 1. So n plus 1. So that means that, what do we have here? We have cross multiplying. This times 2 is 182 is equal to, open this bracket, n squared plus n. So if I rearrange, I'm going to have n squared plus n minus what? 182 is equal to 0. This is what we have. Okay, so now I'm looking for two numbers whose product is 182 and sum is 1. So the two numbers are going to be 14 and 13, right? Because if you multiply 14 by 13, you're going to have 2 here. This time this is 3 plus 1 is 4. This is what? This is 1. So you have this 2, 8, 1. So that's it. Okay, now we have it. So we have n squared plus 14n minus 13n minus 182 is equal to 0. And so we have n. Okay, and so we have n bracket n plus 14, okay, minus 13 bracket n plus 14 is equal to 0, like this. So now we have clearly n plus 14 bracket n minus 13 is equal to 0. So this implies that our n is equal to minus 14 or 13. But of course, it's a positive answer we're going to find, right? So n is going to be equal to 13. We ignore the negative because sum has to be positive. So now, what are we finding? We are looking for the 13th term. So this implies that T13 is going to be equal to, the first term is A, right? A is what? 1. Or let me write the formula. Tn first is equal to A plus Tn. Sorry, you can see that. You can see that clearly. Okay, now we have Tn is equal to what? A plus n minus 1 times t. So that means that our t for 13 is going to be equal to, the first term is 1 plus 12 times 1. Okay, is that correct? Okay, which is equal to 13. So there are 13 terms. The last term of the triangle is 13. Okay, that's it. So let's go to the next question quickly. This question says that a game consists of placing seeds in 24 cups arranged as below. So you see, this is the first cup, 2, second cup, 3, and second cup, 4, then 6, then 8, and so on. So these are the cups. Okay, a player puts 2 seeds. A player puts 2 seeds in the first cup, 4 in the second, 6 in the third, and so on. How many seeds will be required altogether if the player continues to the 24th cup in this way. So we are looking at the sum now. So I can form my AP here now because it's clearly an AP. So I can say solution. This is an AP because the first cup has 2, the second cup has 4, the third cup has 6, the fourth cup has 8, and so on. So this gives me an AP, right? This is an AP. Because it's an AP now, the question says, how many seeds will be required all together? That means that what is the sum of the 24 terms here? There are 24 terms here, right? I don't know what's the value of this 24 term. I can find it, but we are looking for the 24 terms summed together. So the first thing is to write my formula, okay? Or let me get my data first. Get my data. A is equal to 2. Common difference D is equal to 2. And then what again? I'm looking for the sum of 24 terms. S24, like this, is equal to what? Question mark. That's what I'm finding, okay? That's what I'm finding. So, but this implies that N is equal to 24 now. N is equal to what? 24. I'm looking for S24, question mark, but this implies that N is equal to what? 24. Now, I will use the formula. This is the appropriate formula to use. Sn is equal to N over 2 in 2A plus N minus 1 D. This is the appropriate formula to use. If you use the other one, you do not have the last term. So this is what you use because you have everything here. So therefore, S24 is going to be equal to 24 divided by 2. Then the first term is what? 2. You put it. Then plus 24 minus 1 times the common difference is 2. Put it. Now we have 12 because 24 divided by 2 is 12. Then I open this bracket. This is 2 times 2, 4. Okay. Plus this is 23. 23 times 2 is 46. So we have 12 times 50 now because 4 plus 46 is 50. So 5 times 50, 12 times 5 is 60, then 600. We have 600 seeds all together. Thank you.